Hi, my name is Elizabeth Talburt. The date is May 20th, and I'm located out of Niceville, Florida. So, of all the labs that we did this quarter, my favorite lab was Lab 23, which had to do with current voltage and Kirchhoff's laws. The reason why I really liked this lab was because it was very hands-on and in-depth, and we got to play with circuits and observe and measure elements of circuit theory. I thought it was really interesting um, that this lab seemed to line up really well with the expected results. I had some issues with some of our earlier labs in how well my predicted versus experimental results lined up with the theory. For instance, the rocket lab, my rockets just weren't really following the laws of physics, and they flew off in the wrong directions and kept hitting my ceiling, so I couldn't get accurate measurements. But this lab was pretty easy to get very accurate measurements that were very close to the predicted predicted values that were calculated in the pre-lab or in the post-lab question section, so that I really liked. I think electricity is interesting and it's one of my favorite topics, and I like learning about the different effects that different circuit elements have on current and voltage, and it's very interesting to be able to actually measure those different voltage drops or the current of electricity that's actually flowing through the circuit. So in the first experiment, it had to do with series and parallel circuits and how these configurations affected current and power. So I actually have part of Lab 23 Experiment 1 set up, and this demonstrates how the voltage that passes through the circuit decreases when it goes through a resistor. So the voltage drop from here to here, or the voltage from this point to this point, it's higher at this point than it is here because there is that resistor in a way, and whenever it passes through a resistor, the voltage drops or decreases. And this can be demonstrated by the apparent brightness of the LED light that's in the circuit. So when the voltage is passing through both of these resistors, it has less power going to the LED light. But if you bypass one of the resistors, like with a jumper wire, the light becomes brighter because the voltage going into the light is greater than what it would be when it would be going through both of the resistors. So I thought that was a really interesting demonstration of physics where you could actually visualize the theory that was being discussed in the textbook. The next experiment also explored parallel and series circuits, but more in depth. Instead of a visual like the LED light, it was a quantitative comparison of numbers measured across the circuit. So here is the table for experiment 2, and it shows the different numbers measured across resistors in series versus resistors in parallel. And it was interesting because you got to see how dramatic the difference was when measuring current and voltage in these different configurations. Experiment 3 demonstrated the loop and junction rule. So the loop rule states that voltage drops across a loop in a circuit all sum to 0. So this is the diagram of the circuit that we built in this lab. And here is an image of the circuit that we built in this lab. And in this diagram, I've drawn the two loops that go through this circuit. So according to the loop rule, the voltage drops across each of these loops should sum to 0. The junction rule states that current entering and leaving a junction are equivalent. So if you have 3 amps of current entering a junction, that junction splits off into 2 or 3 different wires. The current across each of those wires, if you sum them together, will equal the current of that original wire before it split. This was also demonstrated in the lab, and we measured the current across different spots of the configuration and concluded whether or not they obeyed the junction rule. And I thought that was very interesting because they did follow the rules. And I think it's interesting when the lab predictions match what actually happens at the end of the lab. And here is a table of the results from this lab experiment. Overall, I really enjoy working with circuits. Sometimes when you have the circuit in front of you versus the diagram on paper, it can be a little bit confusing, but I find with the more experience that I get with playing around with circuits, the more apparent the arrangement becomes, and I like their demonstration of the properties of electricity and how current and voltage are affected by whatever medium they're passing through. Thank you for tuning into my video.